Hello everyone. We have had lots of sessions on inverse trigonometric functions, including illustrations on inverse trigonometric functions. Frankly speaking, it is endless. So let us have one more session on inverse trigonometric functions. In fact, in more illustrations category, it is our third session. Okay. So let us start with the first one. And first one is, if cos inverse x is equal to a and sine inverse 2x under root 1 minus x square plus sec inverse of 1 upon 2x square minus 1 is equal to 2 pi by 3 and x lies between 0 and 1 by root 2, then you have to find out tan inverse of 2x. Now, there are so many things given. Let us use them one by one. My first attention is towards cos inverse x equal to a. And that cos inverse x equal to a, if I take cos on both sides, would lead to x equal to cos a. And since x is between 0 and 1 by root 2, that puts condition on a, and a is between 0 and pi by 4. I hope everyone understands that how I am writing a lies between 0 and pi by 4. Okay. Now, look at the equation given. It is sine inverse of 2x under root 1 minus x square plus sec inverse of 1 upon 2x square minus 1 equal to 2 pi by 3. Everywhere in place of x, I will be substituting cos a, and that would lead to sine inverse of 2 cos a into under root 1 minus cos square a plus sec inverse of 1 upon 2 cos square a minus 1 equal to 2 pi by 3. And I can further rewrite it as sine inverse of that 1 upon 2 cos square a minus 1 part I have written as 1 upon cos 2a, and that under root 1 minus cos square a I am replacing by sine a, and hence finally on simplification I write it as sine inverse of sine 2a plus sec inverse of sec 2a equal to 2 pi by 3. Mind you please, now this step, the next one what I am going to write, this has to be written carefully. Sine inverse of sine 2a can be written 2a provided 2a lies in range of sine inverse. Sec inverse of sec 2a can be written as 2a provided 2a lies in range of sec inverse. So we will have to see where does 2a lie. 2a lies between 0 and pi by 2, and hence we are free to write sine inverse of sine 2a equal to 2a. You are fortunate. Okay, and sec inverse of sec 2a is nothing but 2a. Without much further working, we have got that left hand side would be 2a plus 2a, which is 4a. So 4a equal to 2 pi by 3 would lead to a equal to pi by 6. And a means your cos inverse x. So cos inverse x is pi by 6. So what is corresponding x? X must be root 3 by 2. What is question? Question is regarding tan inverse of 2x. That means tan inverse of 2x would be tan inverse of root 3. And tan inverse of root 3 is nothing but pi by 3. So my correct answer is C. So there were so many things, but if you do it, like with all patience, one by one, if you, like simplify, then things are quite simple, I would say. Now I move from here to the next one. And the next one is, the function f is defined as fx equal to cot inverse square root of x into x plus 3 plus cos inverse square root of x square plus 3x plus 1. And this is defined on the set S, where we have to find S. S means here must be the domain where function f works. Now, if I have to get domain, that means basically we have to get condition on x. So the first thing what comes to your mind is that fx equal to so and so many things I am writing. So what is the feasible region? When I say feasible region, I meant that cot inverse of something you are writing there, that values what you are writing there, they should be something which will make cot inverse a meaningful function. Now same is with cos inverse also. And hence I start putting conditions. Cos inverse x if I write, then cos inverse x is defined only when x is between minus 1 and 1. That means if I am writing there cos inverse of square root x square plus 3x plus 1, then that under root x square plus 3x plus 1 should be in minus 1 and 1. Actually, minus 1 is not required because square root would be a non-negative quantity. So I will be using this condition for cos inverse there, and also for cot inverse we have to see. Cot inverse x is defined for all x actually. So as such, under root of x square plus 3x, what is written with cot inverse, it is a real value. I know. But then what should be the condition? Condition is, since you are writing that x into x plus 3 inside square root, it should be a non-negative quantity. And due to cos inverse part, I write that x square plus 3x plus 1 should be between 0 and 1. Why between 0 and 1? Because square root is a non-negative quantity. So obviously x square plus 3x quantity written inside square root also should be non-negative. So x square plus 3x plus 1, that should be greater or equal to 0. And due to the fact that that quantity has to be in the domain of cos inverse, it should be less or equal to 1. Now, when I see this, I realize that x square plus 3x, I am saying it should be greater or equal to 0, and x square plus 3x is between minus 1 and 0 also. So what is the only option left? Isn't it that x square plus 3x should be equal to 0? And that leads to x can take value 0 and minus 3. And so the correct option for S is set containing minus 3 and 0. So answer is A. Now this question was different in the sense that where you are using domain of two functions and then finally domain of the entire function. Correct. Now I move from here to the next one. And the next one is the number of solutions to the equation tan inverse of square root of x into x plus 1 plus sine inverse of square root of x square plus x plus 1 equal to pi by 2 is. And then we are given 4 options and we have to pick up the correct one. Now understand this, that it is equation. It has to be meaningful for certain values of x. There are two functions written there, tan inverse and sine inverse. So we will have to keep everything in mind and work. Okay. So that means we are working on what is the feasible region for which equation will have some meaning. Okay, I proceed from there and I write, since inside square root with tan inverse, I am writing x into x plus 1. So obviously it has to be non-negative. And with sine inverse, I am writing inside square root x square plus x plus 1. Even this should be non-negative. Mind you please that x square plus x plus 1 has in it x square plus x, which is appearing in the first equation. And that I am saying it is non-negative. So does that not say that x square plus x plus 1 actually should be greater or equal to 1? Why greater or equal to 0? You can refine further. And finally, from there I write that square root of x square plus x plus 1 is greater or equal to 1. But what is the condition for sine inverse? Sine inverse function would be defined when square root of x square plus x plus 1 is less or equal to 1. On one side you are saying it should be greater or equal to 1. On other side you are saying it is less or equal to 1. So what is the option left? It should be nothing but equal to 1. And if you say x square plus x plus 1 equal to 1, means we are saying actually that x square plus x should be nothing but 0. And finally, we get x equal to 0 and minus 1. So we have two options. Now mind you please, we have not solved the equation. Question is regarding number of solutions. What we have found right now is the domain for which equation is meaningful. That means we are saying equation could be meaningful only for two values. That does not mean they are solutions. They are possibly solutions. So what do we do next? That we try to actually substitute x equal to 0 and x equal to minus 1 in the equation and check, and we realize that both satisfy the equation. Means domain was nothing but set containing 0 and minus 1, and solution set also turned out to be nothing but set containing 0 and minus 1. So how many solutions does the equation have? It has two solutions. So the correct option is A. Now we have taken 3 different questions where inverse trigonometric functions were appearing. They were not straight away related to domain or any particular property. I mean, you have to be alert. Any property can occur anywhere. So only alertness is required and practice is required. Okay. So when I meet you in the next session, again, I will be bringing something new. Till then, stay tuned. Thank you.